Hi everybody, my name is Sebastian Eigner. I'm the coach for the team Mindsight of Siemens CT Mobile, and today we're going to show you a cool system that combines visual search and crowdsourced labeling. I'd first like to take a moment to thank our customers, Asa and Rebecca, for giving us this wonderful problem, as well as our project leader Zardost, who unfortunately can't be here today but is hopefully watching in the live stream, and of course our 10 great developers. So today you will be taken through this presentation by Daniel and Nareen, so take it away.
Thank you, Sebastian, and hello everybody. So you all know Siemens. Siemens is a company constantly building and creating new large and complex systems. And, oh, sorry, I forgot this. Large and complex system, and this is of course a big challenge for the employees of Siemens. And we want, in our trailer, we want to show you one of the first challenges. So sit back and enjoy. Thank you. So let's recapture the problem we just showed to you. So we have a Siemens worker, and he is operating a complex machine. And at the same time, he has a specific purpose in head. And of course, he's interested in a specific kind of information. But if this information is stored in various places and in various file formats, which is a problem. And additionally, this information is hidden between chunks of information he's just not interested at the moment. So how can we solve this? In our visionary scenario, we are addressing this problem by equipping the user with state-of-the-art AR technology. This allows him to simply scan the object. This is then sent to our powerful engine where it is classified. And after classification, our engine retrieves the information based on the user's needs, send it back to him, where it is projected directly onto the machine for convenient use. Of course, these machines are not only used at one place, but at multiple locations. We want to connect these places, let the users share their knowledge, and maybe more importantly so, let the users add to our classification by sharing data about new and existing machinery. So what are the requirements for such a system? First and foremost, of course, we need the object recognition in place. We talked about the context-based information retrieval and the AR information projection. Those are needed to have the information conveniently for the user available. And last and not least, the crowdsourced data aggregation for sharing data and improving our classification. And now Nareen will introduce you to our models.
Thank you, Daniel. Let's take a closer look at our system by looking at the top-level design. So, as we said before, we have a Siemens employee who's working with an object that he's completely unfamiliar with. By using the Mindsight app, he can scan the object using either his mobile phone or his smart glasses, such as the HoloLens. In the background, several images of the object will be captured, and they will be sent to the Mindsight engine, particularly the classifier located in it. Using machine learning, these images will be used to recognize the object and to retrieve the label associated with that object back into the app. After the user's validation, this label will be then sent back into the engine, and any kind of information regarding that object will be retrieved from the knowledge base back into the app. Then, using AR, this information will be projected onto the object for the user to see. Our second use case encapsulates the crowdsourcing aspect of our application. And this time, instead of a single user, we have multiple users in different locations, all using the labeling functionality of the Mindsight app. The users can capture images. They can also attach labels and metadata to them. and they can feed them back into the MindSight engine. This use case helps us enrich our data set and make sure that our classifier is always updated. As you see, we have a lot of components, and now let's take a look at how they are related to one another. Again, we have a user who has multiple scanners who can take images of various objects. Each image will have a class, which is a label. Additionally, metadata such as location and Wi-Fi can be attached to both images and labels to improve our classification. Labels can also have resources in the formats of documents, external links, audio, and video attached to them. And labels and their associated images and resources can be managed through a dashboard, which is used by a designated manager. So far we saw how things look from the user's perspective, but what really goes on behind the scenes of our application can be seen from the subsystem decomposition. In the case of labeling, for example, images that are labeled and attached with metadata are encoded, and they are sent to a communication controller in the MindSight engine. They are decoded here and sent to a coordination engine, which can either send it to a classifier in the case of classification, or in the case of labeling, it will send it to a data handler. The data handler will then place the image into a repository. The data handler also has the ability to issue a retrain command to retrain the classifier, and it does this by keeping track of the images that are being added. After a certain threshold has been reached, it issues this command to retrain the classifier, and we do this multiple times a day to ensure that all the newly added information is updated and our classifier always stays at the latest version.
Hey, what went wrong? What went wrong? I can fix it. I can fix it.
Guys, it's fine. It's just a false alarm. Hey, Rao.
Hey.
How did you solve the problem area today?
I didn't know. I just used the MindSight app. It guided me through.
Can you help me with this one, please?
Yes, sure. So see, I don't need to know what this object is. I simply point my camera to the object and it shows me what it is. It's an oscilloscope.
It knows what it is.
Yeah. And that's not all. You can click on the label and it will show you all the relevant information. So see, it shows instructions, audio, and video.
Amazing. No wonder you know how to solve it. But how does it know these objects?
App crowdsources the knowledge of all the employees. Any employee can take the picture of the object and label it. So let's take an example. Maybe we can take the object as a bottle. Yeah. So we go to the label and we take the picture. We mark it. We upload it. It asks for the label. So here it is bottle. And okay.
So now the system knows about it.
Yes.
Oh, amazing.
But I don't know what's actually going on in the background. Maybe we can ask our manager if you are free.
That's a good idea.
Yeah, sure. Hey, Humera. Hi.
Hello.
Can you guide us what's going on in the background of the MindSight app?
Yeah, sure. Why not? Can you show us the dashboard? Okay, so first we'll see the overview tab. Here you can see the last retraining date, the total number of images that are used for training that are being stored in our database, and the manager can also use this tab to do the prediction. That's how it works.
So what's the last retraining date?
You mean this?
Yeah.
It's something technical. Basically, we have some super cool MindSight algorithm going around that learns about the uploaded images and that are being trained on them. And that's how it do his work.
So that's a magician.
Yeah. Okay, let's go to the labels tab. Here, you can see all the object information stored on our server, the label names, all the retraining images, and the resources attached to it, who created it, and when it was created. You can also add a new label at the start. I see someone just created a new label, bottle.
That was our step.
Oh, great, that's how it worked. You created an image, you uploaded it along with some resources, and it appears in the dashboard. We manager can also add resources to these labels from this resources tab. And here, you add resources, and then they appear here, and they also appear in your mobile app.
Oh, no wonder the MindSight app is amazing.
Yeah, it's amazing.
Yeah.
Thank you, Mera, for such a cool insight of the
welcome.
MindSight.
Yeah, so first thing I'm going to do today is download the app. And make
Yeah,
my life
sure,
easier.
why not?
Thank you. So let's have a last look onto our current status of development. So you've seen in our demo that we were quite successful with the object recognition already, and with the crowdsourced data aggregation realized through the labeling functionality you saw and the dashboard. We're still working on the context-based information retrieval and the AR information projection, but we're looking forward to show this to you during the client's acceptance test. Thank you, everybody. Maybe the whole team on the stage? We are quite a big team, actually. Are there any questions from the customers?
Yes, but first let me thank you for this amazing work that you've done, and I'm really looking forward to seeing the AR representation of the results that you have in there. So my question is, while you've been working on this, Apple came out with 2 new technologies, ARKit and CoreML, and I wonder if you could comment on how those could be used in either this or the next version of MindSight.
So I will probably hand over to Rao. He's kind of our AR expert.
Hello. Hi. Okay. So basically, Apple ARKit seems very promising. The thing that we were not using it for this project is because it's in the beta version, and it requires iOS 11, which is also in beta version. So I don't think so anyone will take the risk of beta version installation, especially in these conditions. Yeah. And it also requires some processor power with like S7 Plus. It was working fine, but not with iPhone 6. So these were the things that we have to keep in mind. But given that we found the latest version of AR Toolkit, which is just released a week ago, and it is also like very promising. It has many other new features which are somewhat close to ARKit as well. So that's why we are working on AR Toolkit, and you'll soon see very brilliant results. Yeah.
So I'd just like to add is, if we use ARKit, of course, it will be more future-proof for the whole application. But currently, because of the beta state, so it's really hard to, because at least we have to change all the devices as well. And not all devices can support iOS 11.
And okay, thank you. Have you looked at CoreML as well for the? I mean, currently using TensorFlow in the background. Would it be feasible to use the capabilities of CoreML in the future sometime?
Actually, CoreML also included in iOS 11, so it's still the same issue. So it's not possible at the current moment, but it is possible to use it. But still, we can't like use a buggy beta version, and because AR Toolkit still the new version in beta, but still at least it's also open sourced, and we can manipulate it the way we want. Yeah, of course. Of course, we're gonna like if we will finish like the AR Toolkit implementation, and if we find like it's very feasible to work on ARKit, of course we're gonna do it.
Okay, so that's for a follow-up.
Yeah.
Thank you.